I think it would be interesting to hear what your opinions are on just how exciting, surprising, profound, interesting, or boring the breakthrough performance of AlphaZero was.
Okay, so AlphaGo knocked my socks off. That was so remarkable.
Which aspect of it?
That they got it to work, that they actually were able to leverage a whole bunch of different ideas, integrate them into one giant system. Just the software engineering aspect of it is mind blowing. I've never been a part of a program as complicated as the program that they built for that. And just the, like Jerry Tesaro is a neural net whisperer, like, David Silver is a kind of neural net whisperer too. He was able to coax these networks and these new way out there architectures to do these, solve these problems that, as you said, when we were learning from AI, no one had an idea how to make it work. It was remarkable that these techniques that were so good at playing chess and that could beat the world champion in chess couldn't beat, your typical Go playing teenager in Go.
Mm-hmm.
So the fact that in a very short number of years, we kind of ramped up to trouncing people in Go just blew me away.
So you're kind of focusing on the engineering aspect, which is also very surprising. I mean, there's something different about large, well-funded companies. I mean, there's a compute aspect to it too.
Sure.
Like that, of course. I mean, that's similar to Deep Blue, right? With IBM. Like, there's something important to be learned and remembered about a large company taking the ideas that are already out there and investing a few $1,000,000 into it, or more. And so you're kind of saying the engineering is kind of fascinating, both on the with AlphaGo is probably just gathering all the data, right, of the expert games, like organizing everything, actually doing distributed supervised learning. And to me, see, the engineering I kind of took for granted.
Mm-hmm.
To me, philosophically, being able to persist in the face of like long odds, because it feels like, for me, I would be one of the skeptical people in the room thinking that you can learn your way to beat Go. Like, it sounded like, especially with David Silver, it sounded like David was not confident at all. So like, it was like not. It's funny how confidence works.
Yeah.
It's like you're not like cocky about it, like, but
Right. Because if you're cocky about it, you kind of stop and stall and don't get anywhere.
yeah. But there's like a hope that's unbreakable. Maybe that's better than confidence. It's a kind of wishful hope and a little dream, and you almost don't want to do anything else. You kind of keep doing it. That seems to be the story.
But with enough skepticism that you're looking for where the problems are and fighting through them.
Yeah.
Because there's got to be a way out of this thing. Yeah.
And for him, it was probably there's a bunch of little factors that come into play. It's funny how these stories just all come together. Like, everything he did in his life came into play, which is like a love for video games, and also a connection to, so the 90s had to happen with TD Gammon and so on.
Yeah.
And in some ways it's surprising, maybe you can provide some intuition to it, that not much more than TD Gammon was done for quite a long time on the reinforcement learning front.
Yeah.
Is that weird to you?
I mean, like I said, the students who I worked with, we tried to basically apply that architecture to other problems, and we consistently failed. There were a couple really nice demonstrations that ended up being in the literature. There was a paper about controlling elevators, right? Where it's like, okay, can we modify the heuristic that elevators use for deciding, like a bank of elevators for deciding which floors we should be stopping on to maximize throughput, essentially. And you can set that up as a reinforcement learning problem, and you can, have a neural net represent the value function so that it's taking where are all the elevators, where are the button pushes, this high dimensional, well, at the time, high dimensional input, a couple dozen dimensions, and turn that into a prediction as to, is it going to be better if I stop at this floor or not? And ultimately, it appeared as though for the standard simulation distribution for people trying to leave the building at the end of the day, that the neural net learned a better strategy than the standard one that's implemented in elevator controllers.
Yes.
So that was nice. There was some work that Satinder Singh et al. Did on handoffs with cell phones. Deciding when should you hand off from this cell tower to this cell tower.
Oh, okay. Communication networks, yeah.
Yeah, and so a couple things seemed like they were really promising. None of them made it into production that I'm aware of. And neural nets as a whole started to kind of implode around then. And so there just wasn't a lot of air in the room for people to try to figure out, okay, how do we get this to work in the RL setting?
And then they found their way back in 10 plus years. So you said AlphaGo was impressive, like it's a big spectacle. Is there...
Right. So then Alpha Zero. So I think I may have a slightly different opinion on this than some people. So I talked to Satinder Singh in particular about this. So Satinder was like Rich Sutton, a student of Antti Barto. So they came out of the same lab, very influential machine learning, reinforcement learning researcher, now at DeepMind, as is Rich, though different sites, the two of them.
He's in Alberta.
Rich is in Alberta, and Satinder would be in England, but I think he's in England from Michigan at the moment. But he was much more impressed with AlphaGo Zero, which didn't get a kind of a bootstrap in the beginning with human trained games. It just was purely self play. Though the first one, AlphaGo, was also a tremendous amount of self-play, right? They started off, they kickstarted the action network that was making decisions, but then they trained it for a really long time using more traditional temporal difference methods. So as a result, it didn't seem that different to me. Like, it seems like, yeah, why wouldn't that work? Like once it works, it works. So but he found that removal of that extra information to be breathtaking. Like that's a game changer. To me, the first thing was more of a game changer.
But the open question, I mean, I guess that's the assumption, is the expert games might contain within them a humongous amount of information.
But we know that it went beyond that, right? We know that it somehow got away from that information because it was learning strategies. I don't think AlphaGo is just better at implementing human strategies. I think it actually developed its own strategies that were more effective. And so from that perspective, okay, well, so it made at least one quantum leap in terms of strategic knowledge. Okay, so now maybe it makes three. Like, okay, but that first one is the doozy, right? Getting it to work reliably and for the networks to hold on to the value well enough. Like that was a big step.
Well, maybe you could speak to this on the reinforcement learning front. So the starting from scratch and learning to do something, like the first, like random behavior to like crappy behavior to like somewhat okay behavior. It's not obvious to me that that's not like impossible to take those steps. Like if you just think about the intuition, like how the heck does random behavior become somewhat basic intelligent behavior? Not human level, not superhuman level, but just basic. But you're saying to you kind of the intuition is like if you can go from human to superhuman level intelligence on this particular task of game playing, then so you're good at taking leaps. So you can take many of them.
I believe that the system can take that kind of leap. Yeah, no, and also I think that beginner knowledge in Go, like you can start to get a feel really quickly for the idea that certain parts of being in certain parts of the board seems to be more associated with winning, right? Because it's not stumbling upon the concept of winning. It's told that it wins or that it loses. Well, it's self-play, so it both wins and loses. It's told which side won. And the information is kind of there to start percolating around to make a difference as to, these things have a better chance of helping you win, and these things have a worse chance of helping you win. And so, it can get to basic play, I think, pretty quickly. Then once it has basic play, well, now it's kind of forced to do some search to actually experiment with, okay, well, what gets me that next increment of improvement?